Okay. Uh, Good morning, all. My name is Tanzeel Shaikh. I'm a machine learning engineer from GAC Logistics, and I have been in software engineering past 8 years. It's pretty recently that I switched over to a machine learning engineering profile, and my first project is one of the projects that I'm actually going to show it to you. So I'm not going to have any company data out here. It's going to be all test data. However, I'll be showing the problem statement of what exactly the problem is there. So our company is a big corporate company. We have offices all over the world. And one of the most common problems that happens with corporates are that the data that is being entered, like for example, if we look at this picture out here, the data is being entered from different parts of the country, of different parts of the GAC company in this case. And this data is customer names. So let's say if a person is entering Apple in one place, he might enter Apple with a single P. A person that's entering Meta might enter Facebook in some different country. Both of them either are parent, children, subsidiaries, or alternate names, or maybe abbreviations of the same company. So because of some business validations, there cannot be a central database. There are different data centers for every particular country. And finally, there is a major data clerk at the group headquarters consolidating all the data from different parts of the offices into a main data center such that it can actually streamline the business reports for the business stakeholders. So the idea was to basically implement a particular solution, a GenAI solution that solves this particular problem, removing the extra work that the data clerk does. So cutting short to the, like I did explain the problem statement. So cutting short and what the idea is right now about is, and my main focus about this entire project is about agentic RAG. And in agentic RAG, I'm very specific that we are dealing with something called self and adaptive RAGs. These have been papers published a while back, but they're pretty famous. And how are we doing it? I'll directly take on to the process flow of how we are doing it. Right. So many of you know basically what naive RAG is, and you have certain context from a retriever. You pass it to LLM and you get the answer. But there is always the user intent is not there. So sometimes you rewrite the query, you do a query analysis, you do a multi-hop query to LLM, back-to-back multi-hop, and therefore you basically have something like this particular architecture that we see over here. So a self RAG is basically a correction to the naive RAG, and an adaptive RAG is somewhere you basically do a multi-hop reasoning with the same LLM. So I'll take down to you my solution, how my solution is actually working right now over here. This is also, I'll also explain you what is happening over here. This is not a low code implementation. This is a fork of something very famous these Chinese guys have built, that's RAGflow. I'm personally not a fan of Llama Index or LangChain frameworks to build my RAG applications. I have been using RAGflow since a very long time, and the number of stars that these guys have are 27.1. So, this RAGflow, I have forked it and I have actually put it on my own VM. And in this VM, I have actually made my own components. And how this is working, I'll actually make a walkthrough to you. So the first thing is, if I'm going too fast, just let me know. I might jump a bit. Okay, cool. So yeah. So coming back to the solution that the RAGflow, using RAGflow we have done is over here is, as soon as I get a data to consolidate from my user. So if I show you the demo over here, I do get the AI asking the data clerk to actually enter the group that you need to consolidate under. So let's say alphabet group is the group to get consolidated under. From the particular database, it actually picks up all the alternate names that alphabet group has with the particular things to do this. So you can see the alphabet group is a Google group, and all the names related to the alphabet, may be it spelling mistakes, the customer subsidiaries, or the children, or the parent, all of them are being listed over here. So how this is happening is, in this particular thing, there is like if anybody of you have actually used LangGraph or any of this, we are heavily depending upon engineering over here, where we are routing the flow of code, where we are routing the flow of in which direction we need to basically take our user query to. So the first over here is when a user is typing the particular group that it needs to consolidate under, it checks in a particular database whether that particular subsidiary is existing or not. So let's say if I have a very private company, I don't have any subsidiary names, I first check in my database, and then if it does not happen, it goes to a router that checks, okay, if this is not there, then do that, if this is there. So this is a purely logical operation happening. So we are not putting the whole burden onto our LLMs. We are actually navigating, routing a particular logic based upon the data that we actually having. So again, so this is basically using your stateful RAG mechanism, stateful agentic RAG that we have seen. And in the routing, if you don't have anything in subsidiary, we are basically using a search web. Now I'm using a perplexity over here, but I also wish to use Bloomberg's or somewhere we can basically get all the financial companies. But financial companies, these are public listed companies. For other things, we might need some more private companies. So right now I have actually looked at perplexity as this. After that, we have a location remover. So this is basically something to do with query analysis. So as I had shown you over here in the particular self RAG over here, this particular thing that we have, that there is something called query analysis happening, and there is a query rewriting as well. So whenever we have a query rewrite happening, we are actually doing nothing but we are modifying the user's query, or we are modifying the user's data so as to put the less pressure onto the LLM itself. So let's say if my company name is having Alphabet India or Alphabet USA, Alphabet Sri Lanka, any of this, my location remover is actually removing those locations and then finally sending it to my vector DB. This vector DB is nothing but your hybrid search. Now this entire heavily is being based upon the hybrid search. And many of you might know that the hybrid search is actually based upon two things. It's about your term similarity and your vector similarity. And it's I'm using Elasticsearch in this case. So that's actually taking the RRF, that is the reciprocal, the weighted average of both vector and term similarity. So once that goes up over there, it then goes to my batch generate. Now I'm doing something over here. There is something called multi-hops over here. In this, I'll actually show you the code. I'll walk you through the code very much. And after that, again, I'm going and fetching the party codes from the database, because I'm not asking, the idea about the entire thing is not the LLM doing the heavy work. Let the other parts do the heavy work and make sure the LLM is actually giving the perfect output. The main reason why most of the agentic RAGs fail is basically the output that is being expected by a particular agent is not getting. So you need a CSV from an LLM, you don't get that. You need a JSON from an LLM, you don't get that. So let the heavy lifting, let the other software or logical components do that for you, and let the LLM do what it is actually there. So therefore, I am specifying that do not retrieve me anything except party codes, some particular codes. It again goes to database to fetch the names that I had that was actually there in the vector database, and then finally the answer. So I'm actually going to give you a very run through. So here I have actually shown you, I'll actually give you a run through of what's happening behind the scenes. And actually, I'll also show you the response that I'm actually getting from this. So Alphabet Group, we already checked Alphabet Group, I think so. Oh, we already have Alphabet Group. So I'll show you the logs from the Alphabet Group. Please free to ask anything that is there inside of it. So yeah, there you go. Yeah. So the first thing that's happening over here is, as soon as I start my RAG flow over here, yes, this is the Alphabet Group that has been asked about. So from this Alphabet Group, we are actually doing a query out here to get all the subsidiary names for the Alphabet Group. Now this is nothing but a complete search that's happening from this particular module that we have seen over here, this module. This module, perplexity module, because my custom subsidiaries were not there in the database, it's routed over there, and all kind of subsidiaries are being mentioned in this particular thing. So the Alphabet Group is having all these values, and this then goes as a location remover. So in this case, there is no location remover, but since in my database we had like a lot of locations, so therefore this goes to another LLM to actually do a location remover. And then finally, I'll take you the knowledge base, and this knowledge base is where I'm actually ingesting my data. So the way we are ingesting data is over here. I'll just show you to that as well. So no, this is not the one. There you go. So how I'm ingesting my data over here, I'm simply having a code underscore ID and I'm having the name, the clean name of the customer name. Now, the important thing that we need to understand over here, that this entire chunk is an Excel record and it actually gets embedded into the Elasticsearch. But this is your metadata. So this is not getting embedded. What's actually getting embedded is only the name. So the most important thing is, again, to understand is the data that you need to embed. Do not put your entire data along with your IDs into your embedding module. So I know that this is basically going to be a metadata filter from where I can actually filter my data. And this is the actual thing that's basically getting ingested into the vector database. So into the Elasticsearch. Now, after that, it has been ingested over here. I am then going to show you that what exactly are we doing with the okay, I was over here actually over here. So then once we basically feed this, you can see there is a lot of what do you call, lot of data that we see over here that's actually coming. Now these are the chunks that have been retrieved, and we can see that there are two things that have been retrieved over here. One is a vector similarity, one is a term similarity, and one is a similarity out here. The vector similarity is nothing but having a KNN. So Elasticsearch natively supports hybrid search in that. So I'm using a KNN over here. I can also show you where this particular thing is happening. So in a mapping.json file over here, we can see this is actually the configuration file for the Elasticsearch. This is if people have been doing NLP before Gen AI, there has been, you might have known TF-IDF, that's term similarity. And this is the logic for the term similarity that's happening. So because my documents are not that big, it's just a simple Excel record. My weighting for particular term similarity is only going to 0.2, and my major weight is actually getting to vector similarity in my case. And I'll also show you where this is happening, the dense vector. So this is basically where my dense vector is getting categorized as. This is my cosine similarity it is going into. So both this, the vector similarity and the cosine similarity, is getting a weighted similarity to say 0.06. Now I do have a threshold of 0.3. Now this particular threshold, I also have actually done one of the experiments because you need to understand that whenever we basically try to filter out the data, we need to actually see what kind of threshold we need to put onto. So the threshold over here is 0.3, and how I have come to that threshold is again using another stuff that I can show it to you if it's there. I'm actually missing my display today. This is my screen is too small. That's why. Yeah. Not this. Any questions that might come up over here, it's fine. So what I've done over here is I've actually done a kernel density estimation of hybrid similarity scores. One needs to understand that whenever we are basically making a threshold of 0.3, I'm putting all the hybrid similarity scores onto KDE plot. I have actually made this plot without any scikit-learn. Important is to avoid using libraries when you can actually use your actual functions to see that what kind of plot it is happening, and then using that, I'm then using a knee locator, the needle point, to actually understand that where my particular point has to be for my threshold value. So that's at 0.3 over here. So because this actually bifurcates the entire score, because most of the times we don't have the actual the ground truth. In my case, I do have the ground truth, but in cases where we do not have the ground truth, this is an actual thing of to basically make sure that our threshold value is to this level. So I've done that, and I'll walk you through the code as well right now because I'm taking too much of this. So Llama Index, LangChain, all of them have basically made these components, and you have LangGraph, which is actually in LangGraph you're putting all these components into a cyclic graph, and then finally you just run the cyclic graph, a directed cyclic graph to different components. Exactly the same logic is being used over here. However, here you are able to basically run through the entire thing by yourself. So let's look at this particular thing. You can see this. All the software engineers out here can actually understand this way better. This particular run command is what is actually running a cyclic graph. Now, this cyclic graph is what we see over here. Yeah, 2 minutes. Okay. So I don't know how to do it. So do I need to go through the code? It's like it's a big code. It's a big code base, and there are a lot of
questions and then go.
Oh, sure. Any questions out here?
I actually have one.
Yeah,
So
sure.
Backflow, you said that you
Yeah.
did this and then after you customized it.
Yeah.
What's stopping you from using other services like N8N or Make.com and others? Because they also provide similar visual layouts and
it's an amazing question. The reason why I started with Rackflow is because I did not find any of the libraries doing a context-aware chunking. I had my first question that if I have a document which is a tabular format and let's say the table actually goes beyond 2 pages and I want to chunk the data, so most of the chunking algorithms will actually not chunk the entire according to the layout of my this except unstructured. Right now, if you have heard about it. So these guys actually have done this thing and they have done amazingly well. So I can actually show you also that how they're doing it. It's one of the technical documentations of our this is one of the documents that has been there. Now this entire table is being chunked as one particular chunk and that goes in embedding. So when I'm asking what's the cycle count code, is it 10 or 11, what's description, it knows that what is the context about it. If I have a heading, I have bullet points, and if I ask something about the bullet points, the heading is not up and the bullet is not down. So most of the libraries out there which have frameworks I've actually worked with, they did not have a context aware chunking, except AWS had this particular thing, but they are paid and you had to basically use a bedrock for it. So I saw it very long back. Yeah. But then AWS actually also solved the problem. Unstructured did, but unstructured did not solve it the best way in how actually Rackflow guys did that. So which is why they actually have it over here called deep understanding of your documents. So they have written over here very well. Somewhere I am not sure about that. And the another best part about is the system architecture that I've actually built over here. So they're using, whenever I'm ingesting my documents, I'm actually not ingesting into an API call. I'm actually ingesting into a task that's nothing but a Redis queue. As an in-memory Redis queue working, it goes to this, and then meanwhile, while I'm actually working on my actual code in this, the task is like getting dispatched, chunks are getting called, and finally it's getting ingested in the vector database.
So just to understand, what you're saying is that document gets added to a Redis queue.
Yeah.
And then there's a chunking process happening which feeds off of Redis.
Yes. So it's like how we have a message queue broker, be it RabbitMQ, be it Redis, or be it Kafka. You're just simply putting a message onto a message queue. It's actually, there's a consumer at the other end consuming that particular payload, embedding it, putting it into the vector database, and then going for the next batch of data. So the best part about it, it's actually giving a full ecosystem. So if I'm going LangGraph, if I'm going Llama Index, if I'm going all these things, I'm heavily dependent upon their modules. I like these guys because I can customize it there, and also they give me a full a low code platform. But the low code is not that great. You need to actually do some kind of engineering in it. You need to do some development into it to get it to work the way you want. So the idea was to basically, and finally, there are some good results that I actually got over here with this. Finally, I'll just top it off with this. So in this, there are three things. There's a hybrid search, LLM round 1, LLM round 2. With the self-RAG, as I said, there is a multi-hop query happening to my LLM over here. So the LLM, basically, after the first hop, it's again going call back to the second hop. The ones who actually know about adaptive RAG and self-RAG, reflective tokens might actually know what is happening over here. So I won't go into details of that paper, but we see that the number of false negatives that come at the round of LLM2, it's actually the orange line that you see over here. The orange line actually takes care of the negatives, like the false negatives, the false positive that had been done by LLM1 round. So this is one thing that really helped with the agentic Rackflow. Any questions?
I said 2 minutes, 5 minutes.
Yeah.
I have one question.
Yeah.
So we're talking about Rackflow, and I've heard based on the Rackflow, I've heard there's a limited amount of customization when it comes to the advanced options. So I'm curious on your end, was it did it meet your needs basically based on this project? or is it something that you were looking for based on Ragflow specifically on top?
So yes, they had these amazing components. They have built everything. But for me, I needed something called batch generate. I needed multi-hop processing. I needed to basically use these kind of workflows. So actually, to start implementing that, yes, they are incorporating into future releases. But then it's a very easy peasy job. Actually, if you know Python, if you know to know how to write these bits of code, you can actually do it. So like I have forked this repo and then I can customize it to my own company's needs and use it for as a modular RAG. So we have the naive RAG, advanced RAG, and modular RAG. So the approach is to basically go to a modular approach and have these built.
Yeah, thank you very much.
Thank you. All right. Thank you, Tanzeel.